So now we've got different proteins within the cell. What are some of the proteins you've learned about so far?
Integral. I don't know.
Well, did you go over leak channels or anything?
I don't know what that is, but we talked about the different kinds of proteins there are. There are proteins that let stuff come in,
Like carrier proteins?
but transport proteins.
Transport, carrier, okay, yeah, so let's do this. Okay, so there's kind of a rule with proteins, is they need to be the right size, shape, sorry, I can't write right now, and the right charge. Okay, so right size, right shape, right charge. If it doesn't have those, it can't pass through. So the transport proteins, we have leak channels, and it does exactly what it sounds like. It just lets the chemical leak in or out, however the pressure's pushing it. And then we have gated channels. And gated channels simply don't let things leak. So it's going to be stopped by something, or there won't be open until it's the right voltage, or there's a ligand floating by that needs to open it up. So, for example, you'll learn about this soon, but when you have a cell, there's going to be an electrical current that travels around cells at certain times, and that if it reaches the right voltage, then this door is going to open up. And say we have a different protein over here, a ligand gated. The right ligand is a chemical signal, or just like
We
a,
talked about this yesterday.
You did?
Mm-hmm.
okay. So a ligand's a chemical signal. So if we have the right one, right size, shape, and charge, fits kind of like a puzzle piece, and it connects into this, then it's going to open up and let whatever chemical we need into the cell.
Okay.
Okay? With carrier proteins, we divide it into 3 different kinds. Uniport, which means it's either going this way or it's going this way into the cell. We have symport, which just means that there's 2 going the same way, either in or out. And then we also have antiport, which means one's going one way, one's going the other way. So you'll see something like this in your book. Right?
Mm-hmm.
I call this the alligator. So this is your molecule. Your protein's here, it says, oh, we fit together. It's going to kind of change shape a little bit, open it up, enter the cell, and go back to normal.
Yeah.
That makes sense? Or it could have 2 going in there, 2 going out type deal. Okay?
Mm-hmm.
You get it so far?
Yeah.
Okay.
This is funny because yesterday he was making hand motions for this. It was really funny.
Like this.
Mm-hmm. He was like, either it goes up, it goes down, or it goes up and down at the same time.
You sound like a creepy teacher. I love it. That's how Brother Shaw is. Like, everybody's always laughing. Oh, has he talked about active transport?
Yeah.
Yeah? Yeah. There's also something called secondary transport. And the main difference is secondary transport is having to do with ions, like potassium or chloride or sodium, right? We talked about earlier. So active transport is just referring to something that needs energy in order to transport it. So you'll have these concentrations in your cells, like inside the cell you have a lot of potassium, and outside the cell you have a lot of sodium, right? And very little potassium. And so if you think about it, if you've got a lot of water up here and a lot of water down here, it's going to want to flow down there really fast, right? But if they're even, it's not going to flow very well. So say we have this high water up here, low water up here, it wants to flow down, but say we want to get the stuff that's already down here to flow up there. Can you just get rid of gravity for a second and let it do it? No, you need a pump, right? And so we use something called the sodium-potassium pump. Does that ring a bell?
Mm-hmm.
So you'll use the sodium-potassium pump to pump potassium really where it shouldn't be going. Because there's so much in there. Usually things flow high to low.
Right.
This is going to be flowing low to high because of the pump. And so you have your protein. There's a lot of potassium in here, a lot of sodium out here. And we're going to take the little potassium that is out here in the cell, pump it in, and pump the little sodium that's in here and pump it out. That make sense?
Mm-hmm.
And so in order for us to do that, we need ATP to come by. ATP attaches, the molecules line up, say we're ready to go. It separates, so it's just a phosphate, and then ADP leaves. Molecule transferred, and then it releases the phosphate as well. And then on the other side,
What does ATP turn into?
ADP and a
What?
phosphate.
Gotcha.
So it's adenosine triphosphate. And then you have a phosphate here, a phosphate here, and a phosphate here. You get rid of one, it becomes adenosine diphosphate. That makes sense?